Hello, students. Good evening. Welcome to another class of Vedantu, Karnataka. This is Catherine, your physics master teacher. How are you all? Let me quickly check if I'm audible and visible. Yes. Oh, I'm very audible. Hello, Harshita. Hello, Lakshmi. Hello, Anita. Welcome to the lesson. So, you might all have seen that we have started our official KCT batch and NEET batch. So every day the KCT classes are going to happen at 7 p.m. Okay? So today this is your first physics class and I'll be starting with some small portions today from electrostatics. Okay? So in today's class I'll give you a lot of tricks and tips to solve these big electrostatic problems. Okay? So I'll give you some, simple equations to solve big problems. Yeah. Hi Shashank. Hi RXBTCC. Hi Anita. I already said hi to Anita. Hi Harshini. Hi Attitude Girl. Hi Ammu. How are you all? I hope you're all doing good. How many of you? Thank you RXBTCC. So, how many of you are done with your unit test? How many of you are yet to write your unit test? Quickly let me know in the chat. Ma'am, first PUC revision for unit test. Ammu. Okay. Hi Sahana, how are you? Hello. How is all of your classes? How's everything? So I'm a little sick today. So if my voice has some issues in between, I hope you'll all excuse me, my lovely students. Yeah. No, the climate is not that good. No, it's always raining. And how many of you are healthy? How many of you are sick? Let me know in the chats. Anybody with cold, cough, fever? Okay, in Pranav's college or school, whatever, it's not done yet. What about the others? Is your unit test done? Okay, the phone is all set. So let's start with KCT. Sorry, KCT PUC batch. So today I'm going to start with electrostatics. I'm sure you have been learning electrostatics for a long time now. You learned it in your PU college or your school. You learned it for your first unit test, or you're going to learn it. And I have also taught electrostatics a lot of times. But today's class is going to be very different from all the classes that I've already done. Okay? Because today I'll be giving you equations in a very crisp format. Okay? Pranav is healthy. Harshini is not done. First unit test is not done. Nanita also it's not done. Okay, very good. So all of you stay healthy. Okay, your unit test is coming. Make sure you write it very well. Okay, all this says a person who's sick. So let's start electrostatics. So the main focus in today's class will be the portions that are very important for your KCT. Okay, so this is not, I will not be covering everything for your PUC, but main focus will be on topics for your KCT. Okay, but obviously I'll cover the syllabus. So the first thing that I'm going to discuss today is Coulomb's law. The very famous Coulomb's law. I'm sure all of you know Coulomb's law. By now, you might all know Coulomb's law. Even if you don't know, it's okay. We're going to learn it now. So for Coulomb's law, I'll teach you in a very simple manner. Okay? So imagine there are two charges. Yes? This is charge A, charge B. Now, if they're opposite charges, they will attract. If they're the same charges, they will repel. Any doubts with that? Two charges will either attract or repel depending on what kind of charge it is. Yes, the force by which they attract or they repel is proportional to the value or the magnitude of these charges. Okay, how much charge is there? It is proportional to the magnitude of these charges. It is also inversely proportional to how far the charges are. Okay? So if I have two charges, Now, mathematically, how can I write that? I can say that the force between two charges, Q1, okay, let me draw that first. This is Q1, this is Q2, okay? Sorry. The force of attraction or repulsion between Q1 and Q2 is directly proportional to the product of the value of Q1 and Q2. Okay, so let's say Q1 is a charge of 5 coulombs, Q2 is a charge of 10 coulombs. So it's proportional to 5 into 10, 50. Okay, now F is also inversely proportional to the square of the distance between them. So imagine the distance between these two charges is 1. Okay, so F is proportional to 1 square. If the distance is 0.5, then F is proportional to 0.5 square. Okay, so whatever the distance between the charges is, it is proportional. Yes? Now I will add these two, so I will get F is proportional to Q1 Q2 by R square. Now I'm sure all of you have learned this. Every time you have a proportionality sign, to change that, what should you do? You should put an equal to and a constant. So here I'll put the constant as K. Okay, so I will remove this proportionality sign and I'll put equal to and a constant K. Okay, now this K has a value. What is the value of K? K is 1 by 4 pi epsilon naught. Yes, K is 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught. Now what is my full equation? The Coulomb's law, the full equation will be, either you can write F is equal to K Q1 Q2 by R square, or you can write F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Both of these equations are correct. Now, the value of K, or 1 by 4 pi epsilon naught, is equal to how much? 9 into 10 raised to 9 Newton meter square per Coulomb square. Sorry. Okay. So the value of 1 by 4 pi epsilon naught is how much? 9 into 10 raised to 9. This will be very important when you do numericals. And in physics, numericals is very important. Is this part clear to all of you? Okay. Some basics. Now we'll come to the actual part. Now, the force that we just derived is the force of between two charges when they're in air or in vacuum. Okay, so these two blue circles that you see, those are two charges. Let's say this is Q1 and this is Q2. Okay, and they are separated by a distance R. Alright, so what is the formula? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. Yes, 1 by 4 pi epsilon naught Q1 Q2 by R. This formula we already learned. Now what I am going to do? Imagine I take these two charges and I put it in some medium, like let's say water. Okay, so I put it in water. Now what happens? In between these two charges, there is a medium. Okay, do you understand that? So in between these two charges, now there is a medium. It's not air. There is something. There's some liquid or some gas or some solid, whatever. There's something between the two charges. Now in that case, what will happen to the formula? It will be modified. I'll just take it as Fm because it's the force of the charges in a medium. So Fm will be equal to, same formula I'll write first, 1 by 4 pi epsilon naught Q1 Q2 by, oh, I forgot to put the square, Q1 Q2 by R square, but because there is a medium, you will add a constant K. Okay? Yes, because there is a medium, you will add a constant K. Now, what is this K? K is called the dielectric constant and it depends on the medium. Okay? Now, this equation I can modify. I can write that. So, basically, I can write Fm is equal to F the whole divided by K. Isn't it? Because all the other terms are the same. Force divided by the K. So what actually happened to the force? The value of force, imagine initially the value of force was 10 and K is 2. So what is Fm? 10 by 2, 5. So this is going to be reduced. Okay? Are you understanding? So initially, let's say force was 10 newtons when the two charges were in air. Okay? And then you put it inside a medium which has a dielectric value of 2. What is your new force? It is 10 by 2, which is 5. So obviously, because of the dielectric, the force reduced. And by what factor did it reduce? By a factor of K. Okay? Yes, I want you to understand this concept. Everybody, this concept should be in your head. So whenever you have a dielectric, not a dielectric, whenever you have a medium, any medium, okay, whenever you have any medium between two charges, then the force between the charges reduces by a factor K. Alright? Is that clear? I don't see anything in the chat. Is it clear? Is it clear? Is it clear? D-boss. What is D-boss? Is this clear? Can you let me know quickly? Okay. If it's clear, all of you put clear. Students, you get these notes, okay? Whatever notes you want, all these notes are there on our Telegram channel. So if you have not joined Vedantu Karnataka Telegram channel, please go join the Telegram channel now. Okay, the link is there in the description. So not just these notes, we put, important tips, tricks and all that in the Telegram channel. Alright, your important formula sheet, everything is updated on the Telegram channel. So please make use of it. Okay? Okay, Sahana and Anita says it's clear. Alright, now let's move on. Now there's one more case. Okay? The next case is, imagine this is made out of two different dielectrics. I will not use the word dielectric. Two different mediums. Okay? So let's say I have. Okay, I think I should. Okay, that's okay. Yeah, this is for one medium between the two charges. Yeah, this is for one medium between the two charges. Okay, it's clear to Harshini as well. Super, awesome. Now imagine I have two charges. Okay, I have two charges and I put it in two different mediums. Okay, so this is the first medium. And what color should we put the second medium? Let's put it green. And this is the second medium. Okay? Can you see my head or you see the diagram? And just push it up. Yeah. Okay? So I have two dipoles, not dipoles, two charges. Yeah, and these two charges, they have some force of attraction between them, but I place it in two different medias. Okay? So the violet is one medium, green is the other medium. So let's say violet has a value of K1, green has a value of K2. Okay? So violet has a value of K1, green has a value of K2. In this case, what will be the force? So F will be equal to 1 by, let's use the same color. F is equal to 1 by 4 pi epsilon naught Q1, Q2. Till here it's the same, but a small change. Okay? So you have inside brackets root of K1 R1 plus. Can you see? Yeah, you can see. Root of K2 R2 square. Okay? Root of K1, R1 and R2 has no root, square root. Okay? Square root of K1 R1 plus square root of K2 R2, the whole thing square. Okay? So, this equation, when do you use it? Only when you have two charges and they are placed inside two mediums together. Okay, so two mediums, so they will have K1 and K2. If it's a single medium, then it's just 1 by 4 pi epsilon 0 K Q1 Q2 by R2 R square. Do you understand these three equations? Any doubts till here? Okay, now you might be wondering, ma'am, how did I get this equation? So I can derive this equation, but for your KCT or for your PU, you don't need to know how to derive it. Okay, it's good if you can remember this formula because you need to be very quick in your KCT exam. So you have to remember formulas. Okay, yeah, that's the pretty challenging part for students who find it difficult to by heart formulas. You have to know these formulas. Okay, is this clear to all of you? Any doubts? Quickly, let me know in the chats. Yes, did you all go join the Telegram channel? You're all busy in class. Please make sure you join the Telegram channel because you'll have lots of important things coming up there. Okay, it's clear to Sahana. What about the others? Is it clear to the others? Now, I have one more heading here, distance between them. What does it mean between distance? Okay, it's clear to Anita also. Okay, what does it mean by distance between them? So, you have two charges. Okay, this is the first charge, this is the second charge. Alright, now, it's in air. Can you see this? Yeah, you have two charges. Okay, and there's air between them. Alright, and let's say the distance between them is 10 centimeters. Okay, that's a huge number. It's not that big usually. This is just an example. Two charges, air between them, distance is 10 centimeters. Okay, now same charges. Okay, same charges. Let's say it's at a distance 5 centimeters. Okay, and dielectric constant, let's say it's 2. Okay, so dielectric constant, I say it's 2. So the relationship that you will have to learn here is R dash, okay, which is a new distance, is equal to R divided by square root of K. Okay, I don't know if this works with my values. 10, 5. So R dash is 5. 5 should be 10 by, okay, I'll make this 4. Let me make this 4. I'm just putting random numbers, okay. So it should satisfy this relationship. Okay, so what you should understand here is, you have two charges. If they are in air, they have a distance. Now if you put them in a medium, the distance between them decreases by a factor of root K. Okay, so it was initially 10 centimeter. It reduced to 5 centimeter. So by how much does it reduce? It reduces by a factor of root K. Okay, so the advantage if you know these formulas are, when you get questions, you don't have to derive all that. You can just use, okay, the question is there are two charges. The distance between them is 10 and they are in air. Now you insert it inside a medium, find the new distance if the constant K is 4. That will be a question. You can finish it within seconds if you know the formula R dash is equal to R by root K. Isn't it? Within seconds you can just do the math. Yeah. So what happens? Distance reduces. Okay. So here how many formulas did we learn? The first general formula, The second formula, if there's a dielectric, if it's in a medium, and then the third formula to find the distance, and the fourth formula. Okay? All these formulas clear to you? If you can remember these formulas, if you get any questions related to Coulomb's law, you will be able to solve it in seconds. Yes? Is it clear? Is it clear? Okay, there's one more case. Force in a partially filled medium. Okay? One more case. So this is charge Q1. This is charge Q2. Okay? Charge Q1, charge Q2. Let's say half of it you have a medium. Okay? Half of it you have a medium. The rest is air. The rest is air. Okay? Half of it there's a medium, the rest is air. Now let's just say the distance, the length of the medium, let's say it's R1. The length of air is R2. Okay? Yes? Yeah. R1, R2. It's much clear. So here you have, I think red, K1, K2. K2 is obviously 1. Yeah, the value of K in air is 1. Okay? So in this case, what formula should you use? In this case, the formula you should use is, again, Fm is equal to 1 by 4 pi epsilon naught Q1 Q2. This much is the same. Same old formula. Which formula? Root K1 R1 plus root K2 R2 the whole square. Okay? Now the only difference that will be here is when you substitute the values. So let's substitute the values. Now imagine, so K of air or K2 is 1. Okay? Now let's say K1 is for a metal. Okay? So I say the green box is a metal. Metals always have infinite K value. The constant K will be infinite. So what is it? There's a metal, there's air, and then there is a charge. So let's find out. Let's substitute. So Fm is equal to, it will be 1 by 4 pi epsilon naught Q1 Q2 the whole divided by square root of K1 is infinity into R1 plus 1 into R2 the whole square. Okay? Okay? So this term cancels. So what remains? This will be 1 by 4 pi epsilon naught Q1 Q2 by infinity plus R square the whole square. This whole term will actually be 0. So this will be 0. This can be done in an alternate method as well. You can try it. Fm is equal to what? F by K. Yes. So what will F by K will be? F by which K will you take here? Infinity. So this is going to be 0. Mahadevi, this is all based on Coulomb's law. Okay. So here what I have done is, I've taken Coulomb's law and I'm teaching you different conditions. You will not learn in your PUC. Okay. But in your KCET, you will get questions based on this. So first what we did, we took Coulomb's law. Coulomb's law is mainly two charges. They're separated at a distance. And when they are in air, you have the Coulomb's law formula. And then we put that inside a medium. So two charges, you put it in a medium, you get the second formula. The second formula. Okay. And then you put it in two different mediums, you get the third formula. So when you put it in a medium, what happens? The distance reduces by the formula r dash is equal to r by k. Okay, same thing. Another example I've given here. Same thing. All right. Is that clear, Mahadevi? It's Neru. Hi. Hello. Yes. Now let's apply this in a question. So this is a previous year KCT question. Okay, I think it was 2019, maybe. Something like that. Okay. Are you all ready to do a question? So I want you all to comment the answer in the chat box. Two spheres of electric charge plus 2 nanocoulombs and minus 8 nanocoulombs are placed at a distance d apart. Okay, so there are two charges. They're placed at a distance d. If they're allowed to touch each other, what is the new distance between them to get a repulsive force of same magnitude as before? Okay, so this is plus 2 nanocoulomb. This is minus 8 nanocoulomb, and they are separated by a distance d. After that, what happens is these two are made to touch each other. Okay, they're made to touch each other, and now they have a new distance d dash and new sets of charges q1 and q2. We have to find out d dash. That is the question. Is the question clear to all of you? Yes, no? Can I get some response in the chat? Is it clear? Question is clear? Okay, super. Okay, let's start. So first thing that we'll do is we'll write down the force. So we know from Coulomb's law what is the force? F is equal to K into Q1 Q2 divided by R square. Okay, distance d. So we'll put d square. So for your KCT, you don't write these formulas, but in class I will write down all the formulas. Okay? Yeah, this is the general formula. So I'm finding the force in the first case where they are at a distance d. So let me substitute values. What is the value of k? It is 9. Okay, I'll just put it as k. And q1 and q2 is how much? Minus 2. No, instead of minus 2, let me do 2. 2 into 10 raised to minus 9 times, okay, for q2 is minus 8 into 10 raised to minus 9. The whole divided by d square. Yeah. Why did I write 10 raised to minus 9? Because it's nanocoulomb. 1 nanocoulomb is 1 into 10 raised to minus 9 coulombs. Okay? Is that clear? Yeah? So let me multiply. So I will get F is equal to K times 8 2s are 16. So minus 16 into 10 raised to minus 18. The whole divided by d square. Okay? So this is the force between two charges at a distance d. Any doubts? Any doubts? Any doubts? I see your chat. Okay, I see the chat. I will respond to you after I finish this. Just give me a second. Any doubts here? Really sorry, students. I have a very bad cough. Next, what we're going to do. This is the first part of the question. So now we have two identical spheres, plus 2 and minus 2, are placed at a distance d. So we found out the force here. Next, what are they doing? If they are allowed to touch each other, what happens? Charges are going to be transferred. Okay. So if they are allowed to touch, if they touch, what happens? The total charge will be 2 nanocoulomb minus 8 nanocoulomb, which is minus 6 nanocoulomb. Why did I do minus? Because 8 is negative, 2 is positive. So I'm basically adding the 2 plus minus 8 is minus 6. Okay? Yes. So there are two charges. So the total charge is minus 6 nanocoulomb. So on each sphere, how much will it be? So each sphere will have a charge of, each sphere will have a charge of how much? Each sphere will have a charge of minus 6 nanocoulomb by 2. Yeah. This is going to be equal to minus 3 nanocoulomb, which is minus 3 into 10 raised to minus 9 coulomb. Okay? Yes? Now what I have to find is I have to find out the new force. Yeah, I have the new charge. I have to find out the new force. So let me do the new force. Let me use a different color. Okay. So the new force F new. Okay, so the new force, I'll put it as F1, is going to be equal to, again, K into K Q1 Q2 divided by the distance square. So here what is Q1 and Q2? Minus 3 into 10 raised to minus 9 into minus 3 into 10 raised to minus 9, the whole divided by d square. So this is going to be equal to K into 3 3s are 9, minus minus becomes positive, 9 into 10 raised to minus 18, the whole divided by d square. Okay? Yeah. So now what happens? What actually happened here? You had two charges, plus 2 and minus 8. They were at a distance d. And then you brought them close. So what happened? The charges transferred. Each of them get 2 each, 3 each. Now we have to find out the new distance. So obviously, it's the same charges. So the total force should be the same, isn't it? So when you equate it, the total force should be the same. So from this, can I write that to maintain the same magnitude, okay? To maintain the same magnitude, let's just equate. So F is equal to F1. So what was F? K into minus 16 into 10 raised to minus 18 divided by d square is equal to K into 9 into 10 raised to minus 18. Sumit Kumar, 1 second. Let me just finish this. Okay? Okay? Yeah? So, K and K common. I can cancel it out. So, this is basically D dash. Okay? Put it as D dash. Yeah. So, D dash square by D square is going to be equal to let me do it the other way because I need to find D dash, no? I have to find out D dash. So what I will do? I will divide it. So, D square by D dash square is going to be equal to minus 16 into 10 raised to minus 18, the whole divided by 9 into 10 raised to minus 18. So this is basically 16 by 9. Okay? 16 by 9. Yeah? 16 by 9. So if I take the square root, I will get 4 by 3. Okay? So now D is equal to D dash into 4 by 3. Is that there in my option? D is equal to 4 by 3. No, the option is in terms of D. Okay? So all the options are in terms of D. So how should you write the answer? So you should write the answer as D dash is equal to 3 by 4 into D. So just for things like this, you just have to go to the options. Look at how you should write it and write it down. Sumit Kumar, ma'am, do you remember me? If you... Sumit Kumar is my favorite student from first PU class, okay? Yeah? Yeah. So, FA1 marathon for first PU, we're thinking about it, okay? I'll discuss with the whole team and I'll let you know. Okay, if it's there, we'll do it soon. Yeah? Okay? So if all your friends, ask all your friends to come and comment in the live if they want first PUC marathon. Okay, if I get like 5 to 6 requests, then we'll definitely do it. Alright? So let's quickly look at what we did here. Okay, so what all did we do here? So we had two charges at a distance. Yeah, two charges at a distance, D, and then you bring them both close. So now they exchange their charges. So this is initially Q1 and Q2. Now after they exchange their charges, this becomes Q1 dash, Q2 dash at a distance D dash. So my aim is to find out D dash. That is the question. Okay? I hope the solution is clear to all of you. It's not that complicated. It's a simple problem. Okay? Yes? How many students are there in your class, Sumit Kumar? You'll call your teacher also. Okay. Sounds good. Why they won't see? Any doubts here, students? Is this question clear to you? Can you all quickly let me know in the chats? This is a previous year KCET question. Okay? 35 students. Okay. Okay. Next question. This is also based on Coulomb's law. The force of repulsion between two identical positive charges. Okay. So two identical positive charges. They are repulsive. Okay. And they're kept with a separation R. So R is the separation between them. Okay. Okay. Half the gap between the two charges is filled with a dielectric slab of dielectric constant 4. Okay. So half of the slab is filled with a dielectric slab of dielectric constant 4. The new force of repulsion between the two charges is. Yeah, that is the question. So students, this is where, the formula that I taught you comes into picture. So here, K1 is 4. K2 is just 1 because it is just air. Okay? Now, initially, what happens? What is the force? F is equal to 9 into 10 raised to 9 into Q1, Q2 divided by R square. And then, what is the new force? When there's a dielectric, F dash is again 9 into 10 raised to 9 into Q1, Q2, still the same. But in the denominator, how will the formula be? Root of K1 R1 plus root of K2 R2 the whole square. Okay? This is the formula I taught you because there is a dielectric in between. Yes? Okay? Yes, yes. Is this clear, all of you? Now let's solve this. So this is basically 9 into 10 raised to 9 Q1 Q2 the whole divided by what is the value of K1? It's 4. So root 4. What is the distance? R1 is how much? Full length is R. So the dielectric will be at a distance R by 2. Air will be also at a distance R by 2. Isn't it? Do you agree with me? The full length is R. So this is R by 2. The rest is also R by 2. Yes? Yeah. So this will be r by 2 plus root of 1 r by 2 the whole square. So this is going to be 9 into 10 raised to 9 q1 q2 the whole divided by root 4 is 2. So this you can cancel right away. You don't have to write all the steps, but I will just write the steps because some of them might not understand a step in between, and this is not a class where you know sorry. Yeah, I have a bad cough, as I said. So this is equal to 9 into 10 raised to 9. I have a bad cough, as I said. Reduce the volume on my phone. Yeah. Whole divided by r plus r by 2 square. So this is equal to 9 into 10 raised to 9 q1 q2 divided by 2r plus r 3r by 2 square. Okay? Yeah? Perfect. Now, let's just solve it. So this is going to be equal to 9 into 10 raised to 9 q1 q2 by 9r square by 4. Okay? 9r square by 4. Yeah, Sumit Kumar, I'm a little, sick. But I wanted to take a class, so yeah. 9r square by 4. Okay? Let me take it to the numerator. 9 and 9 can cancel out. So 4 by 9 into 9 into 10 raised to 9. Raised to 9. Q1 Q2 by r square. So this is equal to 9 and 9 I'll cancel. 4. Let me not cancel 9 and 9. I can write that as F. So what is this? This whole term is F. So I can write this as 4 by 9 F. Yeah. So that will be my answer, no? Let me check. Yes. Okay, you can quickly go through this. Just quickly drink some hot water and be back in 5 minutes. Hello. Hello, students. Yes, are you all back? Quickly, quickly call all your friends who left the class. Tell them the teacher is back. Any doubts here? So this whole thing is F. We only have 6 likes in the video. Quickly, all of you like the video. Okay. Next, I'll give you some shortcuts to remember these formulas. Okay. So for the first formula that I'm going to teach you is the formula for equilibrium of a third charge. Okay. So imagine you have 2 charges. Let's say there's a charge Q1 and there's another charge Q2. Okay. And the question is, this is a very common kind of question. And you have to do a lot of steps to solve this. I'm sure you know how to solve it, but I'll give you a shortcut easy method. Okay. Imagine I bring a charge Q3 between these two such that there is equilibrium. Is my class audible? Okay. Students, I'm not able to continue. Really sorry. My throat is not letting me. Okay. So do one thing. Thursday's class, we'll continue this. Okay. So in Thursday's class, we'll do equilibrium of 3 charges. Okay. Maybe this I can quickly finish. There are 2 charges, Q1 and Q2. And I want to bring a charge Q3 between the 2. Okay. So Q1 is at a distance x. And Q2 is at a distance r minus x. Okay. So Q1 is at a distance x from Q3. Q2 is at a distance r minus x from Q3. The total distance is r. Okay. Total distance is r. Yeah. Okay. Now, this formula always starts from Q1, which is the smaller charge. Okay. So Q2 should always be Q1. Now, if you have 2 charges, 2 coulombs and 9 coulombs, the 2 coulombs charge should be at Q1. The 9 coulombs charge should be at Q2. That is a rule. Okay. It should always start from Q1 and Q2 should always be greater than Q1. Then to find X, you can use this formula. X is equal to R is the full length divided by square root of Q2 by Q1 plus or minus 1. Okay, so the square root is only for Q2 by Q1. Yeah, Q2 is the big charge, Q1 is the small charge. Is this clear? Yeah. Okay, so if you get questions like this, you don't have to find out full force, equated and all that. You can directly use this formula. Okay, so with this, we will continue from the next class. Yeah, my throat is a little bad. So next class with full Josh, I'll be back with the same topic. So how do you like these tips and tricks? Let me know in the chat, okay? Let me know in the comments on how this is. And we'll continue like this for all chapters. I'm really, really sorry, students, for this. Okay? Apologies. Really, really sorry. Have a good day. Take care of your health. Don't be like me, okay? Bye-bye. I'll see you all in the next class.